Right, we're going to look at an RL circuit that comprises of a resistor and an inductor connected to an AC supply. That will be the circuit on the right hand side. Here's our old traditional circuit where we have I is equal to the voltage applied divided by the resistor, and that's how we calculate our current. So notice we just had one resistor, so this was kind of straightforward. Now we have to combine the effect of the inductor with the resistor to get an overall so-called resistance, which we now call impedance. So we have to find the impedance, working out what is the combined effect of the resistor and the inductor. Right, given the circuit diagram with a resistance of 10 ohms, 10 millihenry is our inductor, and our voltage supply is 220. First thing we want to calculate the reactance of the inductor. Right, so we know to calculate the inductance, we have to use the formula 2 pi FL. We substitute for frequency as F. So our frequency given is 50 Hz, we'll substitute it, and our inductor is 10 millihenry. Don't forget milli is times 10 to the minus 3. Right, we substituted our values, punch it into our calculator, get a final answer. And we get the answer 3,142 ohms. So that is our inductive reactance. Right. Now we're going to calculate the impedance, so we have to use the formula Z is equal to. So there's our formula. Substitute our values, R is 10 and XL calculated above. Right, our final answer is 31,42 ohms. So now we have calculated the impedance. So the first question, so our goal here is to calculate the current, okay, running through the circuit, but now we've calculated the reactance of the inductor. We now combine the reactance of the inductor with the resistor, and collectively this is now our new so-called resistance, which we call impedance. Now we can calculate the currents running through the circle. A good thing to note with a series RLC circuit, that the current through the whole circuit is equal. Right, so we can see that the whole circle, the whole thing, the current will be the same throughout the circuit. Okay, so the whole circuit has the exact same current. So I total is equal to the voltage that's applied between there and there, and we calculated the overall effect of that over here. So all we have to do is substitute our V and our Z. Right, so now we've substituted, plugged it in, and get the answer in amps. So it's volts divided by ohms. Answer will be amps. Right, so I total will be 7,002 amps. And so now we've calculated the current. Easy. Right, so here we have an RC circuit, and we need to calculate the current. We know that in a series circuit, the current is the same throughout the circle, and at any point in the circuit it will be the same. So before we can calculate the current, we will need to work out what is the reactance of the capacitor. So that will be XC. Then from that we'll have to work out what's the combined effect when working with the resistor, the capacitor and the resistor, and then only we'll be able to calculate the current. Right, don't forget that with capacitance, it's a 1 over 2 pi FC, and we're going to now calculate by substituting the value of F, which is 50, and our capacitance, which is times 10 to the minus 6. All substituted. Now we're going to plug it into our calculator by punching in 2 times pi times 50 times all of that equals, then x to the minus 1, and that's how we'll get the answer. And there we have our answer. XC is equal to 31,83 ohms. Now we can work out what is the impedance by finding the combined effect between the resistor and the capacitor. Okay, that's our formula for impedance. We're going to substitute 20 for the resistor, 20 squared. We're going to take our we're going to take our reactance for the capacitor and stick it in there, and don't forget to square it, and then find the answer. Alright, and if you have a good calculator, you can just plug it in and get the final answer. And then we get the answer, impedance equals to 37,59 ohms. And so now we can go and calculate I. I is equal to V over Z. And now by substituting our 220 and our impedance, we now get the answer IT is equal to 5,85 amps. So now we did a RL circuit and a RC circuit.